Okay, and we are probably live. Starting a few minutes early here to melt the bismuth. Check the sound and video quality and everything. How's the focus? Yeah, probably dash over there and take a look. That's good enough for now. Yeah, I think we're all right with the setup for the video and sound for tonight, even though we're just using the onboard microphone of this laptop that I'm streaming through. We're using a little camcorder, but I think it will be pretty good. And I will jump into more of my typical bismuth spiel when it hits 8 sharp. And whether or not I see people in the chat, I'm just going to go for my typical presentation. Some of those viewers might be me and you, so we'll see. But it could also be people who aren't signed in. But also, if you want to talk to me, you can impersonate me in the chat by typing in the chat, I guess. If you want to let me know something. Or you can also just yell. Be a little awkward. Oh, great. Yeah, there I am in the chat, or my agent, lovely partner, assisting me for tonight. So yeah, when it hits 8, I'll launch into things. I'll try to do most of my sort of standard bismuth demonstration as I would do it, periodically checking to see if there are questions in the chat. And I'll try to keep talking at a medium pace just for the sake of the recorded video, whether or not there are chat questions. Another few minutes before I really launch into it. Yeah. Shouldn't smell like much unless it scorches the paint, but I don't think it will. All right, it's 8, so yeah, I'll start in with the intro. I've got a pot of bismuth here under the camera and center screen. And the first step in making bismuth crystals is to melt it. And it's already starting to melt. It's a little hard to see from the camera view, but I can try to zoom in. I turn the... Oh, is my live view not updating? Whoop, let's pull back out there. Hmm? Mm-hmm. Hmm. Yeah, we're actually close to molten here. Got a good chunk of... Oh, yeah, it looks like my frame is frozen at the moment. Um, so let's just double check that we're capturing the proper device. Huh, did the camera give up? Let's check some of the settings here. Try that. Ah, there we go. Is that filling the screen properly, Paula? No. No? How about now? Oh, and it was the right way up before. Oh. One moment as the fussing continues. There we go. Updating live. Almost completely molten here. And of course the first thing we do after we get it molten is to turn it back off again. You can see there's a nice chunk of bismuth metal there floating in the middle. When I do these live, I usually start with a intro about what bismuth is, what metals are. So bismuth is a metal. And we'll get to what other kinds of metals in a second. Bismuth is the 83rd element on the periodic table of elements. It's right there next to lead. It's considered a heavy metal, but unlike lead, it's generally considered non-toxic. And in fact, one of the, people might ask, what is bismuth used for? That's another really common question, great one to ask at these demonstrations. It's actually a chemical component of the active ingredient in Pepto-Bismol. So, Pepto-Bismol there, and active ingredient is bismuth subsalicylate, which is right there on the label. Don't know if that'll focus, but probably. And for some reason, that's a good thing for upset tummies and stuff. But bismuth has a lot of other uses. You can use it as a non-toxic replacement for lead for where you need heavy metal for, say, radiation shielding. And it also has interesting magnetic properties. You can also just go and read the Wikipedia page for all this, but these are some of the things that I like to talk about when I do these demos. Another thing I like to talk about is structured metal. So it looks like we have a full melt here. And I can sort of poke it with these tweezers. We've got some scum forming on the surface, and I don't want to overheat it too much. And in fact, it usually overheats on the first melt. So I'm going to turn the heat off. And right now, the bismuth is hot and molten. And when it's this hot, it has enough energy to react with the oxygen in the air to form a layer of bismuth oxide. And one word for oxides forming at the surface of a melt of metal is slag or dross, or you can just call it scum. So that I can see what the molten bismuth is doing underneath, I usually want to skim this off, and so I just grab a stainless steel spoon from a thrift store, and I'll wipe across the metal. I can tell that it's very hot right now because of how fast I see these rainbow colors appear on it, and hopefully that's showing up on the camera at my first go with the lighting setup tonight, but this should be pretty good. But as I skim away the oxide on the surface, you see a silver layer just to begin with. That's the pure unoxidized bismuth. And then it very quickly builds up a layer of bismuth oxide. The color change there is a form of structural color. You may be familiar with this from soap bubbles and oil slicks, where for thin films, the color that you see is dependent on the thickness of the film. So that would be the thickness of the wall of a soap bubble, or parts of liquids in the soap bubble, or the thickness of the oil on a puddle. And the reason for structural color, it's still pretty hot, so we'll let it go for a bit. Reason for structural color is optical interference. We have white light that's a mixture of all sorts of different colors of light at different wavelengths. And the color of a photon, a particle of light that we see, and prevent the camera from turning off there. The color of a photon that we see is dependent on its wavelength. So the visible spectrum can be measured in the range of wavelengths of light that we can see, from 400 nanometers down at sort of the blue, violet, or purple, up to 700, which is around the red region of the spectrum, and so longer wavelengths than 700 mean infrared light, shorter wavelengths than 400 mean ultraviolet. My favorite color is around 450 or so for a really nice blue. But what we're seeing with the structural color here is that as that oxide layer grows, the thickness of the bismuth oxide layer there corresponds to wavelengths of light, and it'll interfere with light. And now I've actually got some crystals forming here. Again, not sure how well the camera can see them. I'm going to try to zoom in. And I think, yes, I think I can see on the camera here, you can see this triangular shape. It's actually a bismuth crystal has started forming right there, and if we're lucky, it will be a nice deep crystal down into the melt. One of the oddities of bismuth, that's one of the cool things about it, is it's one of the few solid materials that floats in its own melt. Now, we're all used to ice water and ice cubes floating in the melt, but that's actually pretty rare in the world of things that melt and solidify. But bismuth is another one, and that's convenient for this demonstration because it means I can pick crystals off the top, not just ones that might form from the sides where things are cooling down. That looks like it's getting pretty big pretty fast, and it's going to run into the side soon. So now it's time to start messing with it. I'm going to try to nudge it over here a bit. Yeah. And it is hefty. I'm going to try to pick off some of these smaller ones nearby. Oh, this is a pretty nice one here. So, all right, first crystal of the night. I'm shaking off the molten bismuth to reveal the details. And we'll bring it up to the camera here. See if it'll focus. Probably too close. But you can see that it is changing colors as we watch. We'll probably set this down and take another close look at it later, especially if I can figure out how to get the camera to focus better. And I'll return my attention to the pot of molten bismuth with other crystals happening in it. There's a small one here. I can probably leave that. Searching on the other side. And it looks like some stuff was happening with that small one I just pulled out, and then I'm going to let this larger one go for just a little longer. You never know what you're going to get. I have no control over this process. I have some ideas for some experimentation that I might want to do to control the growth of these things. But those will be for another stream, and usually this demo is exciting enough for me as it is, with just the random luck of melting bismuth, allowing it to cool, and pulling these crystals out. So yeah, we'll waited long enough for this one, and we will give it a grab. And oh, it feels fairly heavy. I mean, it's fairly wide. I'm gonna shake off the molten bismuth again, and we'll see what we've got. Okay, and we've got sort of a pretty cool little city. And this is a fairly typical pattern for what I see on these sort of ones that come from a triangular point. They seem to make triangular or square formations typically, and which corresponds to either diagonal through the crystal arrangement of bismuth atoms or just straight on. Yeah, it's pretty neat. So I'll set this one down as well, and we're gonna look. We might get a few more crystals out of this particular melt, or we might be timed to turn the heat back on and melt again. See if I can get this one here. Not very deep. I usually like the ones that have more three-dimensionality and depth to them. Little cities or abstract sculptures. This is not bad. But yeah, let's turn this back on and remelt it. And I'll try to pick up some of those threads that I dropped earlier that I mentioned, such as metals and crystals. So metals are atoms that they like to get together in crystals typically. And what I mean by a crystal, that's another really important point here, is that it's a geometric arrangement of atoms in space, a repeating pattern. So all, in a simple, you could have a cubic crystal of salt, or a cubic crystal of a metal, or a cubic crystal of something else. And that means that the atoms are sort of arranged in repeating cube shapes throughout space. They have long-range order. If you know where one atom is, you can predict where the 1,000th atom away from it is, if it's one big continuous crystal, or further if it's a single crystal of a material that doesn't have a whole lot of defects in its crystal structure typically. No crystal is ever completely perfect unless it's very small or you get really lucky. Typically, even just thermal energy will mean that all crystals, even your flawless diamond, gem, or whatever, will have some flaws in its structure. But crystal, we mean that they're perfect enough that we can do things or anticipate things, learn things about them with their with the regularity of their structure. And since most of the bismuth was hot, not much was frozen, we're molten again pretty soon. I'm going to give it a little extra heat and turn it off and off. Got a helpful hint offline that I can put I'd placed the bismuth crystals I'd made outside the field of view of the camera, which is less exciting. Probably sort of decorate things here so you can at least contemplate the shapes that I've made, like so. Okay, bismuth is hot enough. I'll turn that back off. We will once again skim the surface. And normally I wouldn't handle these quickly after making them, but we've got them on a nice stainless steel table here. Neither bismuth nor stainless steel are great conductors of heat, but good enough in this case. And now's a great time to speak a word about safety. I am wearing safety glasses. Safety important to protect my eyeballs because I've only got two and I don't want to only have one. But also, I'm relatively confident in doing this because I have done it many times before for many audiences. So, I guess this, right now I am trying this at home. I would say Uh, don't try this at home unless you're a professional like me, or do try it at home if you have a background in working with this kind of stuff. This is probably not a whole lot more dangerous than deep frying stuff. I definitely do not want to dump this pot on me, and I'm being very careful not to get any hot liquid in it because that would instantly splatter it around, probably giving me severe burns. But as long as I don't make any sudden movements and splash it, it mostly just sits there being hot. Oop, oh. Oops. Well, I missed that. Well, let's get the camera back on. One of the basic things about this setup is that I do not yet, and I do not want to set the date or time right now. One of the things about this setup is that I do not yet have a great camera or a way to power this camera so that it stays on. So this broadcast, we'll see how long it goes. One limiting factor may be the battery on this camera. But for now, I'm just going to sort of stare intently and maybe keep talking about crystals and metal and stuff at this. I'm going to stare at this pot of metal that I've skimmed once or twice. Give it another skim. Right. So crystals are a repeating pattern of atoms in space. Can sometimes be a repeating pattern of other things, but usually we just mean atoms, occasionally larger molecules. Sometimes those can be gemstones, but metals typically form crystals, and the crystals are usually smaller than we can see. So if I were to put this spoon or any of these other metal things around here under a microscope, prepare them just right, and look at them with the right kind of microscopes, I could see that they would be made up of lots of little crystals all smushed together, like grains, like the grains of granite or grains of sand on a beach. Call them crystal grains all smushed together. What we're getting with bismuth here is that for some reason, when we've got very pure bismuth, like 99.99% pure bismuth, and these kind of cooling conditions, we form much larger crystals. So, this is a macroscopic crystal. We can really see this thing and see how big it is. But we can also see these square, let's see, the lighting is a little awkward. We can see these square shapes, straight edges. And those straight edges reflect that the atoms in this crystal are arranged in that same straight line, parallel to those straight edges, making up these flat faces that we can see in this crystal. So that's one of the things that's really neat about that, because you can't always see crystals in metal. Sometimes there's other examples, like the sort of modeled pattern you might see on galvanized steel, little patches of different shades of gray, and those are actually big flat crystals coating the surface. Those are crystals of zinc that when the steel is hot dip galvanized, it's dipped into a big pool of molten zinc, and you get these large crystals forming as that zinc solidifies, as it cools onto the steel and performs that protective coating that helps keep the steel from rusting. There are some other examples. Right now I can see one little square crystal forming there, maybe some others going on in here. Sometimes I'll tap it to the ripples will show me where the crystals are. Like now I can see there's a crystal there, there's a little doublet there. I'm going to let all these grow for a little bit. Don't know if this is going to be the best melt, and that's the luck of the draw. Sometimes I get lots of great crystals, sometimes not so many, but it's still fun to, do this and make them, and yeah. One of the things that comes up right now is you might be able to see the center of these square ones, or back when I have the big triangular one here at the center of this one, they converge at a point, and that's sort of the start of the crystal. The whole symmetrical arrangement grows outwards from there. We might call that the seed of the crystal, or the nucleation point, the nucleus, where the crystal starts to form. And one common question is, how do those form? What's going on there? There's a bunch of ways that you could nucleate a crystal when the conditions are right, and that could be a grain of dust from the atmosphere falling onto this pot and nucleating a crystal. This sort of that disturbance, the change in energy when the dust hits the metal, might cause things to start crystallizing. It could also be, I'll go for just tiny, teeny ones there. I'm gonna wait for something more exciting to show up in the middle, and then maybe here if we're lucky. Crystals might be nucleated by vibration. They might just be the random thermal motion that's already in the pot of liquid here. Could be a bunch of things, and that's another thing that I don't really have control of. But you can do some things to do that. So, for example, if I were to insert a cold point into the melt, like just a cold piece of metal, like these tweezers or something that's a little colder, that would pull a lot of energy out of the liquid. The liquid would stop having enough energy to remain liquid and would sort of freeze around that point, and then you'd have a whole bunch of crystals all nucleated at once there. Sometimes I play around with that and you get these little clusters, but I don't think I'll be showing that tonight. Yeah, we'll grab got a few here. I think this one is not going to be too exciting, but I could be wrong. So shaking it off, and oh, looks like I get the warning that the power is going to shut off just a little too late. So please bear with me while I turn the power back on. I'm going to put this crystal down here. Do not set the date and time. All right, well, we're back again. I will try to catch that before it happens. Maybe a little more frequent checks of the camera. Yeah, for whatever reason, and I really wish I knew, sometimes I get these melts where I only get these little square crystals that are flat and relatively close to the surface. They're still pretty. They turn colors when they oxidize outside of the melt, but they're not quite as exciting as the ones with a whole lot of structure. So I'm going to give up on this batch and remelt again pretty quickly here. I don't want to put that quite on the meltable label there. I'll just turn this back on and try again. I'll be right back. All right. Well, still got a pretty good solid crust. When I turn the heat off of this bowl of bismuth, and if you can't really see what's going on here, it's a butane stove. These things are great. You get a little canister of butane. They're just like a gas range. When I turn the heat off, this thing is starting to cool down from all sides because the melting point of this is 273 Celsius approximately. 273.15, I guess, if you want to be really precise, which is around 550 Fahrenheit. So it is pretty hot. It's probably about 22 Celsius as the air temperature here. So it's cooling down pretty quickly. I'm mostly interested in it cooling down at the surface where I can get those crystals most easily. But it's also cooling down all around the sides here. And so one of the things that it would be great if we had some sort of magic see-through vision is it's forming all these crystals in from the sides. Sometimes what I'll do is I will let things solidify for a while, and then I'll pour the bismuth out into another container so that you can see what's left there. And I'm not going to do that just yet, but what I will do is over here, I've got a case where I did that and let it stay frozen. So let me see if I can set this down somewhere that's still in the field of view of the camera. That's not too bad. Maybe over here where there's more light, where I had it before. I think that's a little better. So in this case, you can see all these crystals have been growing in from the sides of the container. That's likely happening to one extent or another every time I do this. But probably what I'll do here is, as cool as this is I will probably remelt this whole thing and we'll get a big fuller pot of metal, which will prime me with an empty pot to do that kind of thing again. And also hopefully to get some larger, heftier crystals out of there. And okay, we're fully molten again. Turn this off. Do one quick skim now. And yeah, sometimes even though I've done this a whole bunch of times, I'm still learning the right timing for how long to leave it on after it's molten. I don't want to overheat it too much. And the crystals probably form better when it's sort of super cooled. Then there's a question of how often to skim it. What I ideally would want to see is after a skim, see the colors changing pretty slowly. But right now it's going pretty quickly. So we'll let it sit for a bit. And of course, if you are here and you're signed into a Twitch account, feel free to ask any questions you'd like in the chat. If you don't have a Twitch account, you could make one. That doesn't, just signing up doesn't cost you anything, and they usually don't spam you with email if you don't want. But totally understandable if you're not interested in making it another internet account. And but if you're a person like that, you may know how to contact me through other means, and feel free to drop me a note if you've enjoyed the stream or would like to ask me some questions about it, or if you think I should or shouldn't do it again. It's been a few hot seconds, so we'll take another skim of another area of the melt. We didn't skim before. Okay. And yeah, you may be able to see from the camera that the colors are changing a little more slowly now. Sometimes when I skim with the spoon in the past, I think I nipped the power save in the bud that time, hopefully. Sometimes when I'm skimming it with the spoon, I'll see little tiny crystals start to form right in the wake of where I have moved the spoon through the liquid. I don't think I'm seeing it this time, but I think this is changing color slow enough that I think we're getting close to about the right temperature. Yeah, that's looking a little more promising. Oh, hey. Someone in the chat. Yeah, bismuth crystals is part of your rock collection when you were a kid. They're very fragile, and it didn't take long for you to learn that. That's true. Bismuth it's not a very, steel, iron, titanium, even copper and bronze, metals that you could make nice structural things out of. Bismuth isn't so great for that. It's both soft, it's easy to bend, and it's brittle. So maybe for like one of these little tiny pieces here, it's cast itself around, oh, there we go. It's cast itself around the tweezer, and this will just sort of break right off, probably bending a little bit before it did. Yeah, it's not the toughest stuff. And it's sort of funny to be soft. Sometimes things are hard and brittle. Sometimes things are soft and tear easily. Like, lead is very soft, but it doesn't really shatter. But bismuth will both bend and shatter. So in terms of handling bismuth crystals, it's best to be pretty gentle with them, not drop them onto hard surfaces. Some people are interested in wearing them for jewelry, and some people do wear them for jewelry. And ways they do that would be to wrap the crystals up in wire. Wire wrapping is pretty popular among jewelry makers these days. And other people you could also cast them in resin. So that then you have a sort of a polyester or some other resin, epoxy resin, supporting them and keeping them together. So despite the slow-looking color changes, okay, it's there's some stuff happening in here near the shadow, and there's some stuff happening right there. If I give it a little tap, you may be able to see, I can see some ripples there. And if I'm lucky, this one will be sort of a deeper crystal. Hope I didn't ruin it by tapping it there, but that's part of the experimental nature of this. So I'm an engineer or a technician by trade, and so I do like to talk about a little bit of the distinction between science and engineering and tinkering here. And although a lot of this is informed by science, I'm trying to share some things that have been learned by science about this material. Most of what I'm doing here is tinkering. I don't have a control. I don't really have variables. I have a if I do have variables, I don't have much control over them, like the random disturbances that might nucleate my crystals, or how hot I'm getting them melt, or how long I'm waiting until I turn it off, or how often I skim. All of those things, if I started to make those consistent, I might get more consistent results with the crystals. I might not, because maybe it's just so random. Anyway, there's an interesting looking one over here. Oh, it's already frozen to the walls of the container. I don't know if it'll be interesting when I pull it out now. Probably kind of neat. So once again, shaking off these drops of molten bismuth, which may create their own little havoc elsewhere in the melt. And this one has a little bit of a funny shape because it was right up against the wall. There's this curved surface there, but we've got more of these sort of spiral square shapes that make it so interesting to look at. So not bad. And we can definitely see that there's another something going on over here. I'll see if I can grab that before it freezes to the wall. It looks like it may have just picked up a hitchhiker. It's hard to tell. Sometimes little crystals will be near each other in the melt and freeze to each other, and you get a cluster that maybe is not actually related. Well, it's a little something. And this is the one I had my eye on from the beginning, but I may try to just sort of clear its neighborhood and maybe pick out this one over here if I can. It's getting away from me. Oh, it wasn't much here to begin with. This one is a very, whoop. Again, apologies for the power off notification. Yeah, so this one is mostly near the surface. It has some ridges and some stuff going on, but not a whole lot to recommend it. And so a lot of these I will remelt after the end of the demo. Some of them I will keep and save for when, you never know when someone needs a bismuth crystal, I guess. Yeah, this big one is, or larger one at the surface. It's about to run into others, so see if I can shake it off a bit. Not too bad. It's got some depth to it, some angles. I think I need, not sure if I need more brighter diffuse light around here or what, but hopefully some of this is coming through on the camera. I'm just sort of festoon the stove at a large enough distance away from the flame that these won't remelt when I turn the heat back on, which I think it is about time to do. So during this remelt, I'll pull out some of the better crystals I've made, and I'll try to hold them up to the camera so that they can be seen well. And see if we can make that an intro to some more topics. So one thing is this one is a good example. You've got these two crystals right next to each other, sort of sharing with each other. And they've got this square stair-step shape. You can see it on the other faces too, and there's sort of some spiraling as well. And I think that is really interesting. And it's also something I get a lot of questions about, naturally, because you don't always see that with other crystals. It can be seen in some crystals, sort of like snowflakes, for example, ice crystals. The phenomenon where it does this sort of linear, angular, steppy thing is called hoppering. And so bismuth crystals are known as hopper crystals because these sort of squarish pockets sort of look like hoppers on a train car, hoppers for, say, coffee to run through, coffee grounds, or for sugar or sand or any granular material sort of stored in a container with a pointy shaped bottom. It's called a hopper. And I still don't have a great first principles explanation for why Hopper crystals formed, but one simple way that helps understand it is to say that when a piece of a substance, an atom molecule, is cooling down, it's going to go from being a liquid atom that has the energy to just float around with all sorts of other atoms, and it's going to go to be a solid. There's energy changes associated with that. So the energy associated with phase changes, a phase change from liquid phase to solid phase, and there's also an energy change associated with becoming part of that solid. So in the case of bismuth, it is more energetically favorable. It's not 100% guaranteed, but it's more energetically favorable for one of these atoms cooling down from a liquid to a solid to stick to the edge of an existing crystal rather than to stick onto the face. So, some of them will be sticking to the edge, some of them will be sticking to the face, but enough more of them will be sticking to the edge that occasionally this will generate new edges. Then they'll step out and you'll get one of these sort of stair steps. But that's the same kind of thing that can give snowflakes their unique sort of serrated or corrugated shape. And you can also see hoppering in a lot of other things, like sea salt crystals may have this sort of pyramidal hopper shape sometimes, like from especially fancy Malden sea salt. It can happen in gold crystals. It can happen in a lot of other things. It's just really, really easy to see it in bismuth crystals, and in fact, it's probably hard to see crystals that aren't hoppered. So we've got things molten again, maybe a little less overheated. Oh, it's still pretty hot. I think I gotta, for one of these upcoming melts, I gotta try to not heat it for quite so long. And then we won't have to wait quite as long for it to cool down. It is good to make sure it's all molten, but the hotter I have the longer I have it, the more slag I make, and I have a few pounds of slag accumulated over the years that I'm hoping someday to maybe try to deoxidize to reduce back to bismuth, maybe with some sort of charcoal assay or something. But that's more of like a weekend backyard kiln project thing, and I don't know when I'll get to that. Hopefully in the next few years. But for now, fortunately, it's not too expensive to just keep doing this casually here and there. I don't do these demos too often these days, and I don't go through bismuth too fast. And despite increased interest in bismuth crystal making as a hobby, or some people got professionally good at it and make a living selling bismuth crystals, it hasn't really changed the price of bismuth too much, or the demand for it that I've seen. Which is another interesting point to segue into, I suppose, is one of the things that's neat about bismuth is that in the Earth's crust, or on the Earth basically, since it's most of what we're exposed to is the crust, we can't really get below the crust in most cases. On Earth, there's only about twice as much bismuth as there is gold. So gold is only half as common as bismuth, but much, much, much more expensive. Gold is just really valuable to people, thousands of dollars an ounce. Bismuth is something like in the range of $10 to $20 a pound most times. I haven't checked lately. So the mass of a little crystal like this is maybe an ounce, and it's really not too much. It is very dense. It doesn't take up a lot of space. For example, maybe like this piece here is maybe 15 pounds of bismuth. It's pretty huge, and it doesn't take up a lot of, or it's very massive. It doesn't take up a lot of space, but it's very massive, very dense. But still, sort of interesting. Gold is around the same density, and just so much more expensive. Probably one of the other reasons that bismuth is cheap, though, is of course there's not as much industrial use for it. There are industrial uses for it, but not as many as gold. The other reason is that it's probably cheap because it's sort of, in many cases, a byproduct. The name bismuth may come from root words meaning sort of like white mass, which was referring to the white mass that was left over when people were purifying lead to do lead things. Maybe they got their silver and then they got some lead left over, and they figured they could do stuff with the lead that they couldn't do with the silver, like maybe stained glass or other sorts of things that you might do with lead before we realized it was good to avoid lead whenever possible. But then they went to purify their lead further, and they got this other stuff that it wasn't silver and it wasn't lead, and it was bismuth. So the fact that it's a byproduct of sort of lead and silver manufacture may also mean that there's a sort of a supply of bismuth that is sufficient to keep it from being too expensive. And this melt is well. It looks like I'm asking myself in the chat how far is lead from bismuth on the periodic table, and it is directly adjacent. They're right next to each other. Bismuth is 83, lead is 82, if I'm not mistaken. I'm really good at remembering bismuth is 83. Sometimes I forget whether lead is 82 or 84. And bismuth is, and also we covered this at maybe the beginning a little bit, but it's always good to repeat and do cycle through some of the information in this demo. Bismuth is not poisonous the way lead is. You can get bismuth poisoning if you eat a whole lot of it, but it's not a chronic poison like lead. We've got some crystals for me here, so we'll stop. I will not skim those right out of existence. There's also a nice little one here. You may be able to see an X. Bismuth is part of the active ingredient in Pepto-Bismol. Bismuth subsalicylate. May be visible on camera. I see the comment about radioactivity. I'll get to that in a second. Oop. This one seems like nice. So this one, again, mysteriously, I think I maybe, and we've lost the video again. Stand by while I turn the camera back on. Let's see, maybe if I tell the camera to record, that will help. Okay. I don't know if that'll drain the battery faster. Anyway, we're back. We've got this crystal that just came out. I'm quite pleased with it. Even though I did things very similarly to my other melts, it went much deeper into the liquid than the other ones. So that's sort of pleasing, and it's got this, just very classic shape. And we may be able to get a few more out of this yet. You may be able to hear the bismuth crackling as I try to remove it from the tweezer. Okay. Go for this. So yeah, bismuth and radioactivity is a pretty interesting topic. I don't know, can't say whether it's the first element to have radioactivity or not, but it has, it was determined through painstaking experiments that it is very slightly radioactive. There's probably a few different isotopes, but the radioactive isotope has a half-life that is, I believe it's greater than the current age of the universe, something like twice the current age of the universe. So it's very, very low radioactivity compared to a lot of other radioactive things. But still, it does, radioactively decay just extremely slowly. And there are some things that are just totally stable and don't do that at all, but it's a whole other topic of nuclear something. I can see the top edge of a crystal here, but I don't think I can retrieve it because I think it's fused to the side. So, yeah. I might be able to work it out here. Sort of. Not sure that was worth it, but we'll see. Sometimes doing that gets crystals with more interesting shapes than the other ones, and this one seems a little bit interesting. I'll try to separate that from the tweezers and pluck a few more out of here, perhaps. This is rapidly freezing over. Yeah, well, there's too much mess for me to deal with, so I'm going to remelt and just try to not remelt quite as much this time. Get a shorter heat cycle. I'll keep a close eye on it. I'm glad to have everyone here who's watching. I'm going to fuss with the camera just a little bit. I think I'll leave it where it is. I don't want to mess things up too much. Yeah, I think don't have a great sense of relative units of radioactivity, but for example, bananas, which are, are the commonplace thing that you don't think are really radioactivity, but contain some radioactive potassium, are definitely more radioactive than probably all this bismuth, I would think. But nevertheless, in case you were planning past the planning many ages of the universe into the future, billions and billions of years, your bismuth would not be around quite forever. Some of it would, I guess, turn to lead. Or it depends on what the decay product is. I don't, more questions for a nuclear scientist that I am not. But maybe things for me to have in my pocket for next time I do a demo. I've got another. Find material science one of the most industrially relevant and not as much publicity with the general public. Thanks for this. As a materials science person, I would sort of heartily agree. And another question after that, would a possibly more slender melting pot yield better results? So yeah, it's a great question to talk about how I might improve on this process. I think this works pretty well for these demos, which is why I haven't improved it much since here. But a slender pot could help, especially if I insulated the sides. So if I had a flat bottom where I heated it and then insulated the sides, then I wouldn't get as much bismuth sticking to the sides. I'd have a larger thermal mass and then a relatively small surface area at the top. Maybe that would make sure that more of the freezing and the crystals were forming from the top down. I think in some senses, these I've got these sort of hemispherical bowls. They actually come from IKEA. In some sense, these are pretty good because the sphere or the half sphere has like a very low surface area to volume ratio. Then this is probably enough. Hopefully I didn't overheat it quite as much this time. Maybe not quite as much. I don't know. We'll try leaving the oxide layer on there for a little longer before we skim it. But yeah, possibly taller and skinnier. I've read that some sort of, bismuth crystals like you might get in a crystal or gem collection set, a rock set or mineral set, educational supply place, might be grown by, it'd have a big pot of bismuth and a lid with a bunch of drywall screws stuck through it, and then the crystals would nucleate and grow on the drywall screws that were immersed in the liquid. Things that I would possibly like to try is rather than changing the shape of this vessel, I might want to use a fiberglass heating mantle or something to try to really maintain the outside walls or the lower walls of the sphere at a higher temperature so they cool off less rapidly, so that the cooling is more focused at the surface, and we can experiment more with that. But I'm also interested in trying to nucleate things with, say, a cold piece of metal like a copper wire, or something that's even actively cooled a little bit to draw heat out of the crystal faster. That's an experiment I haven't really planned out just yet. I have experimented with doing things like using a helping hand to hold a piece of metal in the melt to get stuff to nucleate on that, and it sort of works okay sometimes. I don't think I'm gonna quite try one of those experiments tonight, but it's the kind of thing I might want to do in the future. One thing I'm really interested in doing is trying to control the oxidation a little bit more. And I don't think I want to blanket the whole thing with sort of a shield gas like a welder might do. That would be a lot of nitrogen or argon, and then the influx of that gas would affect the, I'd have to heat it all that much more. And I can't really, I'm using a gas flame to heat it, so if I were going to do it in a totally inert atmosphere, I'd have to do it inside of a glove box or something where it was just electrically heated and just one gas. But I think there are some high temperature heat transfer fluids, silicone oils and some others, that would actually stand up to the 273 Celsius or say 300 Celsius or so of this liquid without combusting or oxidizing. And then I could use those as sort of a shield layer, some sort of oily shield layer. And on one hand, that might be less interesting because then the crystals would come out and they'd just be silvery and shiny. You can also get those if I don't have the equipment to do it right here, but if I were to take one of these crystals that I have made that has all these blue and purple and gold colors on it, if I were to dip it in some hydrochloric acid just briefly, that would strip the oxides off and they'd just be silver. But I think if I had some special heat transfer fluid, we've got crystals forming here on the surface. If I had some special heat transfer fluid, they probably wouldn't block the oxygen entirely, or they would probably slow it down. And then maybe the resulting colors that I got would be sort of a little bit more brighter and more vivid. I think if the crystal is hot enough and it oxidizes enough, it'll cycle through the number of layers that interfere with different colors and not of light enough that it gets sort of dull. The same way sort of the slag gets duller and duller the thicker it gets. But that's another thing. I'm not sure if I'll get around to trying. Again, it always sort of surprises. Sometimes I can tell when a crystal is going to be more interesting based on how high it's floating in the melt. Since the heavier it is underneath the liquid, the more buoyant it will be, since the bismuth is floating in its own melt. This one, got some neat shapes on it. I thought it was just going to be sort of small and triangular on top, but it had more going on underneath the surface. So there's sort of like, maybe a little bit like icebergs. Maybe not. Maybe that's not really a good analogy because those are, just very different materials, different temperature regimes. But the surprise of not knowing what I'm going to get is another one of the reasons that I like doing this. And we've got a few more to pull out here. Wasn't exactly sure what I was grabbing there, but got a few little, just a small little example of the form. And something's going on here. We'll try to, oh, not that. Something's going on here, maybe? Not that. Sometimes you try to pick up a crystal and it comes apart everywhere. So we'll just knock this off and see if any of the others will keep it together before I go for another remelt. All right. Yeah, so what are these? This is what I thought I was getting the first time, with a sort of a very slender, not a whole lot of features. Still turns cool colors as it cools, but not the ones that I find most interesting. All right. This time, once again, my goal is to not get too distracted by talking about stuff while I melt it, so that I can turn it off before it gets quite so warm. Poking around. Every so often I'll try to grab one while the remelt is happening, but usually, and that maybe this is a good one. I find that usually it doesn't, when things are remelting, the features start to really soften, but this one came out quite nice. So maybe I'll try it a little bit more in the future. It's got some good shapes and colors. Well, the colors change, but the shapes are good.
The camera's frozen.
Oh. The camera is frozen. It looks good. Let's see. Thanks for letting us know the camera is frozen. It looks good on one of my ends, but I will try again. Stand by as the feed may appear to go black. Go totally dark. Plug it in again. Maybe this is... We are back. Thanks for letting us know. Appreciate it, and glad it's fixed now. So we're still got a little bit more bismuth to melt here. I'm trying to turn it off a little bit quicker so we don't have to wait as long. I knew that no matter how many things I thought I had ironed out in some test streams that I'd run into stuff here, I wasn't expecting quite as much trouble with the camera, but so it goes. Nothing permanent, at least. Okay, so this is... Yeah, I think... Okay, so let's see. This is... If I didn't overheat it already. One of the things is that when the bismuth that's floating on the surface melts, it's still got some little bit of oxide on it. So sometimes it melts and the oxide stays in the same shape. So you can't really tell that it's molten until you touch it with a, obviously not with my hand, with one of these handy steel implements. One of the things that works in favor of this is that the bismuth, as far as I can tell, stays pure by probably rejecting impurities as it freezes or to the surface there. So despite probably hundreds of cycles of melting and remelting, I still keep getting good crystals that indicate high purity. And when I've seen people who've tried to use lower purity bismuth to make crystals, it doesn't really work well for them. So I don't have to worry about that, at least. And similarly, it doesn't. It not only does it seem to not pick up impurities, it also doesn't seem to gather impurities from the tools that I use. That is, that the iron or nickel or chromium in the stainless steel implements I'm using, or the stainless steel bowl here, don't seem to become part of the melt at all. At least not in any appreciable concentration. That also works for me. Sometimes with different kinds of metals at higher temperatures, you melt the wrong metal in the wrong kind of container, and you find that the container is becoming part of the melt. The melt is eating through the container, and then you've got a puddle of molten metal on the floor. It's not what you want most of the time, unless you're casting into a sand mold that is on the floor, in which case a puddle of molten metal on the floor is exactly what you want, but typically not what we want. And there's Owen. Good to see you, Owen. Thanks for stopping by. Oh, and I didn't see the username before. It just appeared green. I saw that there's Jerry. Yeah, good to see you as well. And let's see. And not Gallardo, I guess. I don't know if I'll pronounce all the names correctly. Yeah, maybe I'll come back to the material science bit. I feel like, material science, in some sense, a lot of it gets covered because it gets covered by proxy, because really is an interdisciplinary field between mechanical engineering and chemistry and physics, and all of those also get some press here and there. But one of the reasons I chose to study it and that I like it is that I think it does cover some different territories. And different ways of looking at things. One of the key concepts that ties some material science together is the concept of the relationship between structure, properties, and processing. So the structure of the bismuth is crystal, but we get these specific shapes as opposed to just this huge lump, because of its properties and how I'm processing it with this molten pot thing here. And to address Julia's question there, um, I'm using 99.99% purity bismuth crystals. There's a number of sources. I get mine from a casting supply company that deals mostly in like lead and tin and pewter, but they're called Hallmark Metals, and they're in Rhode Island. I haven't ordered any in a while, but I think they're very much still doing that. But there's also Roto Metals and other places, and plenty of people on eBay and Amazon who are happy to sell 1 to 10 to 20 pound quantities of bismuth. I think the minimum I'd want to do for making some crystals at home would be about 10 pounds. And they'll happily sell you 99.99% pure bismuth. But lower purity bismuth is available, such as sort of like as pellets for casting into, say, fishing weights. If you don't want to poison your waterways, you might use bismuth fishing weights instead of lead. Or for similarly, if you want to shoot waterfowl in the marsh, you might use bismuth or steel shot instead of lead shot, so that even though you kill some birds, kill some ducks, hunt some of those. Oh, there was something interesting there, but I lost it, which also happens time. Yeah, so those are some other sort of uses for bismuth, but it seems to be in decent supply without the price going up too much. One of the commercial people, or people who's made a living out of it, and has figured out some method of, I think, using a propane torch to get special colors on the surface in a sort of a deliberate rainbow pattern, is the Bismuth Smith at thebismuthsmith.com. I don't think I'll ever want to spend quite that much time making bismuth, but I am sort of curious about the methods. Let's see what the chat has said. Okay. Oh, metallurgist, chemist, engineer from... Nice. And some links to the archive of preprint paper results, which is also interesting sometimes. Oh, I realized I put down a big heavy chunk of bismuth right where you can't see it. So let me hold that in front of the camera again, which is just relating that, coming back to that materials science and engineering point about how structure, properties, and processing, these may have the same structure at the atomic level as the crystals there. This is a big chunk of bismuth. But through the properties of the bismuth and how I process it, we can get this to be very different from all of these. I'll put this maybe where it's, yeah, it can be in view over there. We've got a big triangular face at the surface here. I may still be able to remove it, but this melt is crusting over, so we'll have to get something else soon. Okay. Yeah, so I'm gonna shake this off and remelt. I'm gonna try using a little bit less heat this time so I catch it before it's too molten. Oh, and we had a pretty good big crystal on the bottom of that, so you can see, yeah, about, I mean, I sort of go by the depth into the liquid, and about maybe 20 millimeters, 3/4 of an inch, on a nice sort of triangular plateau. Sometimes, it's tricky to see, sometimes you can still see the central point where the whole crystal started on the back of one of these triangles under the colored oxide layers. It's a little tricky, and I really can't tell how well the camera is doing with this, but I hope you can get some idea of it.
If you put your hand behind it, it'll focus on it.
Put my hand behind, as in like...
Hold it in front of your hand.
I've been informed that if I hold it in front of my hand, the crystal will focus, the camera will focus on it.
Yeah, that's much better.
Uh-huh. Well, that's good to know. So, we've got a nice collection here. Yeah, the not is referring to the materials triangular tetrahedron. I'll try to illustrate with gestures that when we talk about the relationship between properties, processing, and performance. Oh, properties, processing, and performance. Try to keep those in here. And then some people like to make it a tetrahedron instead of just a triangle by saying also, structure, properties, and processing, and then performance is the fourth point. Anyway, I think the debate is still out among the materials science people as to whether they really like to think about the performance or not, but some do and some don't. Either way, it's a handy way to think about all of the solids that we interact with. That is a little bit different than the approach taken by mechanical engineering, which just wants, they really want to, they'll study the properties and the processing, but not as much the structure, and especially the performance. Physicists might be more into the structure and properties, but not so much the processing. And then chemists might also be into all three, but they really want to do it with liquids and gases, and aren't as into the solid state quite as much. But in fact, all of these people work in all of these fields. One academic track or another is not really restrictive. We've got there goes one can of butane. So I'm not totally molten, so I will have to switch out and keep melting this. See how the bismuth sausage is made here. These gas stoves are available at some Asian food stores and of course on great big Amazon. And you get one of these butane canisters and plop it in there. And when it runs out, you get another one and replace it. It has a nice little lock lever to lock it into place for safety. And then a nice piezo igniter. And we're back in business. All right. Glad to see a little activity in the chat. I think I will. I'm going to keep going for now. I'm going to, before this gets too hot, I'm going to turn down the heat. Step away for a very quick water break. You can probably still hear me. For safety reasons, I keep my water far away from the bismuth itself. And if I were a more established Twitch streamer, I would probably have a robot in my chat that would tell me to stay hydrated. Owen asks, have I produced Faraday waves in molten bismuth? I do not believe so. I do not know what Faraday waves are offhand, but that might be an interesting experiment for the future. And inspired by a paper you sent me recently, I think it would be interesting to try crystallizing bismuth onto a little solenoid of copper wire. So I'd probably make a little solenoid of copper wire, maybe donut shaped or just cylindrical. Run a low current through it, or a decent current, and then suspend that in the bismuth as it was solidifying, and seeing whether the magnetic field would make the crystals have strange shapes. I might also try that with, say, permanent magnets, although a lot of permanent magnets will lose their magnetism at molten bismuth temperatures. That is, they'd be above their Curie point, which is the point at which a magnet suddenly can't be a magnet anymore. And okay, a little less overheated this time. Maybe. But yeah, make sure to get this one relatively clean of the oxide. Skim it off the surface here with a spoon. If you're just joining us, what we're seeing here is removing the bismuth oxide, exposing fresh, pure bismuth underneath, which is silver, which then quickly reacts with the oxygen in the air because it's hot to form thin layers of bismuth oxide, which, like oil on a puddle or soap in a soap bubble, change color based on their thickness. I'll take a look at that link later, Owen. Thank you. Ah, well, I think waves due to mechanical vibration are one of the sort of uncontrolled variables in this whole process. There's going to be uh, some vibration at different frequencies and uh, different different frequencies, different amplitudes from, say, just the building I'm in, machinery running in the building that I'm in that's mechanically coupled to the building. Maybe the Green Line construction nearby. There's the light rail project near where I live, or just me talking, or other sounds, air currents. So there, and then occasionally, of course, I will just sometimes physically tap the vessel to see whether that reveals the outlines of any crystals that are already floating in it. So one way or another, I probably have what could be described as Faraday waves. However, I don't know whether they have I cannot yet determine whether they have a meaningful impact. But an interesting experiment that would take a considerable amount of setup to do would be to really try to isolate the setup from vibration in some sort of special air table or something, and use carefully controlled, maybe robotic motion to reach in or put something in there for the crystal to nucleate on, and see whether that would yield different results with how things crystallize. I think yeah, it looks like I skimmed with the spoon, and in the wake of that skimming, we got a crystal there and a crystal there. So this is right at the freezing point now. We'll let these grow. One of the things another question that I get at these a bunch that's interesting to talk about a little bit is seed crystals. And I've sort of used the term seed to refer to the center of a crystal where things nucleate, and maybe that's more of the nucleus. But seed crystals can also be used. People ask me about seed crystals because seed crystals can be used to take a small crystal and grow a big crystal that continues the structure. You could do this with, if you're growing rock candy or salt or copper sulfate crystals from a liquid. You could use a seed crystal to, start things crystallize. Get a whole bunch of small crystals. Pick one that's good. Use it as a seed crystal and suspend it in another solution of the same liquid to get a nice big version of that crystal. For semiconductor manufacturing, silicon wafers are grown from the crystals that silicon wafers are made of are grown from seed crystals in very fancy melting pots that are controlled with vacuum and rotation to make sure that the crystal that the silicon wafer is in the right orientation. And by using a seed crystal to start the growth, they can control that. I can't do that with bismuth because of the oxide layer that forms, but I might be able to do that with bismuth if I removed the oxide layer, such as with acid or something, and prevented it from reforming, such as with an oil or inert gas, and then I were able to introduce it into the molten bismuth without somehow getting things in the way. But that is that's also sort of a more advanced experiment that I'm not too likely to do. It's still a fun possibility to consider. There might be some interesting, I guess, artistic or aesthetic applications if I could effectively continue the growth of certain bismuth crystals. Oh, this one, surprise, surprise. Got a pretty good one here. A good set of features. More of the classic shape. Yeah. Let's see if we can get a few more from this batch.
Hold your hand in the thing as close as possible.
As close as possible to the crystal, Paula?
Yeah,
Yeah.
the back, so that it focuses at the right point.
Oh, whereas this one really didn't do a whole lot. But it was right at the surface. So yeah, it's total look at the draw. This is it's actually still a neat shape here, but a good amount of detail, just less depth. And maybe it's silly of me to be focused on depth, but I sort of want to have things to have the most sort of three-dimensionality to them. At least that's the ones that I prefer. Similarly with this one, it's a bunch of stuff intersecting at the circle, at the surface. Pardon me. And I'm hoping, let's see, that at least some of these you may be able to see the color change happen in real time. I'm pretty sure you can see it from just the overhead. Okay, since I didn't, so I think I didn't overheat this one quite as much. It is cooling off more quickly. Got a few more crystals in here. I've got a little bit of bismuth on the wall there. I'll clean that right up later. I do not think I'll be. I think I don't quite have the setup to vibrate this with an electric toothbrush tonight. It would probably melt the toothbrush, so I'd need to rig up some contraption to transmit the vibration. And but that's a good idea for the future. I think the result of letting it cool with that sort of constant vibration would be lots of small crystals. I think it would be sort of disruptive to large single crystals, and you just get lots more nucleation, which would be much smaller things going on. But it's still worth a try. Oh. Oh, I am hearing there's some focus issues, and that maybe my hand helps with it.
Yeah, it looks better now.
Okay. Otherwise, enjoy the periodic shots of me waving my hands around here. Oh, right here, bismuth crystal just floated up from the bottom, and unfortunately, I'll try to grab it, but oh, hey, oh, well. It was falling apart. That's up. So the let's see. Okay, we're gonna. Excuse me. For this one, I'll bring this back into view for a bit, and we will actually remelt this. To be careful while I'm doing this, I will use a big pair of pliers to lower it in slowly until it floats. Or break it into pieces. Let's see. Grab it by the thick part. And this will give us a bunch more volume to work with. And after this is totally molten, I'll pull it back. I'll pour it back into one of these bowls so that we can see a new creation like that. But now introducing this much cold bismuth to the whole thing is going to take a little bit longer to melt. So make sure to do it at full power. For withdrawing the crystals in an extra oxygenated environment. I've done a little bit of experimentation with an oxygen concentrator to try to use an oxygen enriched environment to cool the bismuth more, or to oxidize the bismuth more rapidly. I'm not sure about the effect of xenon there, since it's noble and should be just as inert to bismuth as the nitrogen in our atmosphere is, but at higher oxygen concentrations, yeah, I think we would get duller colors, not richer colors. I think that if we reduce the amount of oxygen, we'll get brighter colors. But again, it's a good experiment to try, at least with enriched oxygen or other ways of affecting the surface oxidation to get different different or more control over the coloration. Okay, and actually almost all molten here. I'm going to try backing it off so that we melt the center there without turning everything off. Good question about the slag there, not. There is... I do not have a use. I suppose it would be heavy and ballast for something. What I do hope to try at some point is to see whether I can do my own little home smelting or refining from the slag, where I would probably just try to get it very hot with a bunch of charcoal. And so I'd try to transfer the oxygen on the bismuth oxide to the carbon, make carbon dioxide, which would go off as gas, and keep the bismuth that was free to of the oxygen in a reducing environment until it was pure again. And then I'd see, then I'd have a chance to see whether it was pure enough to make crystals, if I could get some liquid out of that. Let's see. And that's a good question there. A concern about fire hazard in an oxygen-rich environment if the bismuth is already around 500 Fahrenheit. I think that really depends on the oxygen concentration. I don't know... And I guess how exothermic the reaction is, and whether it would be self-sustaining. That's something I don't have a good feel for, but would be, that's kind of why I would do it with not a whole oxygen-rich environment, but probably just an oxygen source in a normal oxygen environment, so that there'd just be a small, if suddenly we got metal combustion, it would be easy to just thwart by removing it. Oh, well, the video probably will be available and stored by Twitch for the start of this stream, Wex. Insufficient available space. So I only have a small thing in here. I wonder if I can just, I don't know, I hope the camera won't tell me that it's gonna run out of, nope. So now I probably will have to keep checking to make sure the camera doesn't power off, but at least I got some of this on the video camera. But it should also just be recorded by my computer and Twitch. I might put it on YouTube, as Not says. And I'm interested to hear that you started working with Bismuth a few months ago. Happy to talk with you about your experiences, and if you've been doing any, whether you've been making crystals or doing other work with the metal as a material. Neat. Still got a pretty good... I'm just going to try to leave this chunk here and remelt it on the next pass. Well, this one might be this pass might be a little bit crusty. But yeah, a metal fire is not something I want to deal with, so even if it's just bismuth, we want to be careful with that. Oh, and yeah, there's plenty of stuff starting to happen in this one. Sort of curious how it will go. Let's get this one that was near the side first. It's just a bunch of fragile stuff that I can't pull out. But there's a few other things happening, so we'll see what we get from this. Yeah, copper wire as a seed is something that I've played around with a little bit. I think I've gotten some decent things to grow on copper sometimes, but it is a bit touch and go. I think I should probably try to clean the copper really well first. I don't know why. I mean, I guess it grabs onto steel pretty well. I think possibly the shape of the copper could have something to do with it. Possibly having the copper connected to a cold source to try to conduct more heat out of the bismuth might help. And I think also with something like copper, keeping it using something like a ring stand or one of these sort of helping hand kind of things to hold the copper really steady might help grow more stuff on it. But I think it will probably get you more of a cluster than one of these. And maybe I'll actually, so one of these upcoming melts I will try something like that, where I just try to use one of these tools that hasn't been as hot to make a cold point, and see whether we get sort of a, it usually looks like a little spray of crystals. It doesn't always work, so I don't know if it'll work this time, but we'll give it a try. And oh, a lot of these are, so that we're getting some crystals that are relatively deep in the melt here, but they're all falling apart when I try to pick them up. Not too bad though. Not really wanting to focus. Okay. We're gonna get this good and molten this time. A little or maybe extra molten. There's gonna be some extra slag from all the oxide of the stuff that I put in there. And then we will, oh, and I've got this piece of metal here that I'll put back in here. But then we'll pour it out and we'll see sort of the big crystal cluster alien city thing that was that will form on the inside of the bowl when we pour it. Yeah, watching about water concentration would be a thing to worry about. And a layer of flux. So earlier in the stream, I was thinking I'd like to try using a silicone oil or a high temperature heat transfer fluid at some point to try to prevent oxidation. I'm not sure I'd want to use a, I mean, I think a lot of things you could use for a flux might work, but and might not be capable of contaminating the bismuth, but I haven't really figured that out yet. My inclination would be to use a high temperature oil as opposed to a low temperature melting salt. But on the other hand, maybe the metals in a low temperature melting salt would be exactly the kind of thing that would contaminate the bismuth. But that's, yeah, it's a good idea. And I have a suspicion that it may be how some of the sort of laboratory or teaching supply crystals get made, because I think that they have a thinner oxide layer on them, which would, whoop, great, thanks. Once again, get the warning that the camera is threatening to power off. I think that if you used a flux like that, then when you pulled the crystal out, if you pulled the crystal out, then it would be sort of coated in that flux, which would not totally block the incoming oxygen, but would slow it down enough that you'd get thinner oxide layers everywhere, and sort of, I think you get more vivid colors that way. Yeah. And hopefully next time I do a stream like this, I think I will want to do it in the future. No promises on schedule yet. Next time I do a stream like this, I'll hopefully have one or two of these experiments planned, maybe just some simple things, and also a camera that will not auto power off. Okay, I'm just gonna, yeah, this is all molten now. Turn it off, give it a good skimming. Another potential use for bismuth slag, while we're sort of not too far from the subject, is like many metal oxides, especially ones that aren't super reactive, bismuth oxide can be used in thermite reactions with other pure metals. And I think that's used in some kinds of fireworks called dragon's eggs. At least that may be something that was just on Wikipedia. I haven't actually seen it myself. And I guess that would be also a way to potentially purify the bismuth by sacrificing all of its oxygen to aluminum or something. But that would probably be a lot more violent than trying to smelt it with carbon or something. So I don't think I'm too likely to ever try that. But something that's also a little fun to think about. Okay, so this one, I'm gonna probably skim it a little bit, look for a few crystals, But then we're going to be pouring this out into this bowl over here, and I'm actually going to do it on the side that doesn't have the butane canister. And then we'll remelt the stuff that we pour off in here and admire whatever we have left in here for a bit. And we're going to let this crystallize in from the sides a bit. See, yeah, so it is a, if you have a gas stove, that's great. I think I've done it sort of on electric, or it can be done on electric burners, but it's really hard. Sometimes, I mean, it depends on how, what kind of pot you have and how hot your electric burner goes. I have an induction stove that I don't think would work for this because it will temperature limit, but it would be really cool to, induction is just a great way to melt metals because you just heat the metal directly with magnetic fields. But this is, this is a butane stove. There's the butane canister. And it works really well. It's just like cooking with gas. Turns on and turns off easily. Portable for demonstrations wherever. Relatively inexpensive. Okay. Yeah, okay. The steel cup like that sounds pretty good. And having like a 4-inch diameter means you don't need a ton of bismuth to get a decent depth. So it sounds like a pretty good vessel for doing some experimentation like that. I forget what I think I started with these IKEA bowls actually. I might have used some other kind of small saucepan at first, but no, I had just, the way I got into doing this was somehow I got into a educational supply catalog, Teacher Source, or it has another name as well, but teachersource.com is one way to get there. And I was flipping through it for something else. Maybe I was looking for soda bottle preforms or something else that was sort of interesting. And I saw that they had a bismuth crystal, and it looked really cool, so I ordered one. And then I, as a sort of materials person, I was like, well, how did they make this? And then I looked it up, and it turned out that some Boy Scout somewhere had done a merit badge or a science project on doing it in their kitchen with stainless steel vessels. And I thought, well, heck, I can do that. And so I got some supplies together, and I did. And then I later realized that, not only could I do it, but that not only could I do it, but that it would make a fun demo to do in front of other people. And that was all quite a number of years ago, but yeah, you don't want to. Definitely don't want to have tipping. If I didn't have the prongs of the burner here holding the stove in place, these would also be kind of tippy. I think the center of mass would be stable enough because the bismuth is so dense that it wouldn't be a huge issue, but I still wouldn't want to find out the hard way. And before I pour this out, we do have at least one nice crystal here. And I keep tossing little bits of liquid over towards the wall, but I'll try not to do that. Yeah, pretty good. This should have a pretty good crust all around it, so I think we'll go ahead and pour it out. See if there's anything else. I don't want the, yeah, we'll get this. So for this, I like to use a pair of vice grips. Clamp the lid, the edge here. Make sure this is nice and tight on there. And hopefully this will still be visible on the camera. Go ahead and pour this. Hopefully that, I think maybe some of that sound came through. I mean, it just sounds like a rushing liquid, but pretty neat. And then voila, we have all the stuff that's happening on the inside of the pot every time I do one of these. And hopefully also the video will be capturing some of the color change. I guess this is, let's see if I can change the, angle a bit so it catches more of the light, maybe.
Talk about safety.
Now is a good time to talk about safety again, as I'm reminded by my helpful to talk about safety. So first of all, I've done this a lot. I'm doing this on a metal table to prevent it from burning things. The bismuth also cools off pretty quickly, so it's not that hot to begin with. So I wouldn't want to be doing this with, say, molten iron or molten bronze. I'm wearing safety glasses at all times, except when I take them off to show the camera. Generally, when I do this in public, I make sure that everybody knows not to get any water into the molten bismuth, or to, just to be respectful and generally behave. And usually there's never a problem. So, let's see. Right, use the vice grips for that. It is too heavy for just free-handing. And yeah, through experience and careful thinking about things, I've determined ways to do things like safely pour 10 to 15 pounds of molten metal from one container to another. But still helps to always remind myself and think about how I don't want to get any of this on myself. So what do I do with my slag? I just collect it for now. This is from tonight. I'll probably try to remelt some of this, and I find that from other times. Oh, forgot to show this earlier. While this stuff is melting, and here's one of my nicer bismuth crystals. But then here's another big pot of slag, and have this saved. At some point, I would like to try melting it in either. I might try getting it really hot and then pressing a bunch of molten bismuth out of it, because it's sort of spongy, and then just saving the the leftovers, saving the stuff that's only bismuth oxide after I've extracted some metal from it. But I really like the idea of trying to purify it with charcoal at some point. Yeah. Before I got these, I was actually using a Coleman propane gas stove, and those were a bit more risky. They still had the prongs on top, but they were also stacked on top of a 1 pound propane bottle. Can't really show it on the camera here. The base of the propane bottle had these fold-out feet that kept it pretty stable, and that worked well enough for a lot of demonstrations. But I was much happier when I found out about these little gas stoves and moved to them. And it looks like slag had to be a permitted term, slag is, well, it probably could still be a slur on this channel, but right now it's certainly not. Yeah, I also have no idea if refining the oxide will be easy. I think I have an idea about how I would do it, and I'd like to try, but I don't necessarily expect success. But boy, wouldn't it be, it would be pretty neat if I could. Recover, because I don't have that many pounds of slag right now, and I've gone through a lot of pounds of bismuth, but it would still be nice to. I don't want to have to just throw out all this bismuth oxide mixed with pure bismuth that I can't really use. I'd like to be able to recycle it. I don't think my local scrap dealers are interested in bismuth scrap. I think it would probably need some kind of, maybe like a graphite crucible in a gas-fired furnace, possibly with some sort of stirring or agitation to do something like that. But it would be, yeah. So as a non-toxic substitute for lead for something that's heavy, could be a pretty good ballast. But yeah, I don't know. And there may be some other things to do with it, but I certainly haven't thought of them. I guess you could, since since you could strip off the oxide layer with probably don't even have to get that strong of hydrochloric acid, you might be able to. I gotta keep doing this. I don't know how much the battery is getting low, so I will probably. If the battery makes it till 10, I will stop it around 10. If the battery cuts out sooner, then you'll be treated to a dark screen while I narrate that the battery has run out. But I think, so you might be able to, and that might be something worth trying a little bit, is just a little bit of muriatic acid or hydrochloric acid, maybe even acetic acid like vinegar, and some of the slag to see whether you can at least dissolve the oxide. You probably get some bismuth in solution. And then you might be able to use that to separate some of your pure bismuth that's mixed with the slag out, and then you might be able to get a bismuth salt from that reaction that you can also do something with the bismuth salt there, like whether that's bismuth chloride or bismuth acetate or whatever. So that might be something that maybe I'll even try something like that on stream. But probably try it off stream just to see whether anything interesting happens. I don't see, the only bismuth salt I know of that people do anything with is bismuth subsalicylate for, once again, Pepto-Bismol. This stream is not sponsored by Pepto-Bismol, but maybe it should be. No, I'm not really interested in doing sponsored content. Anyway, yeah, I have to imagine that bismuth forms salts readily like so many other metals, but again, I don't know if any of those salts are particularly interesting. And then you might be stuck with a bunch of bismuth salt that is just as useless to you as your bismuth oxide slag. Well, okay, we got some things forming in here. And since a bunch of stuff is forming in here and it's pretty cold, I'll try this sort of cold point seed that I've alluded to before. So there doesn't seem to be anything happening here. I'll touch the pliers to it for a second. Pliers are a bunch colder than the bismuth around it. Pull that out. I got a bunch of stuff on the pliers. But probably right where I did that, some crystals will start to grow just because the pliers conducted away a bunch of the heat from the bismuth. Put that little nub back over there on the side to melt next time. So meanwhile, I'll try to clear the environment for getting that one later. Got a little try this one. It's fairly easy to see the central point again, and the corresponding sort of crystal structure, triangular pattern on the side, but triangular pattern on the other side. The longer I talk, the more I tend to run the words together. And one thing that I like to notice is how the triangle is just the slice of the cube. So we got a sort of a right angle there, but a triangle this way. And that's sort of the same thing here. So it's all the same crystal structure, just sometimes we get one face at the surface, sometimes we get another for these floating crystals. This one is having a little trouble getting free of the tweezers. And we'll see if I may have pulled out all the cold stuff around the cold point on this one. I don't think there's, yeah, okay. So that definitely didn't work, but I'll try one more time on the next melt, and I'll see if I can get one more good crystal out of this one. Bismuth oxide used as a seed. Well, since it's an oxide, not the pure metal, it's going to have a totally different crystal structure. So, well, and this is, I was talking about a little before, we could distinguish between seeds and nucleation points. We could definitely get bismuth to, it is rhombohedral. We could definitely get bismuth to grow on bismuth oxide. but it will not pick up the underlying crystal structure of the one crystal. It'll just start a new crystal with whatever orientation it finds to be favorable based on that bismuth oxide surface, and who knows what that'll be. Yeah, this is looks like this melt is not so great, but we'll keep trying. And we'll try, and I'll see if I can do the cold point a little bit differently. So yeah, you can nucleate on anything. I mean, I think one way of nucleating, I mentioned it could just be a grain of dust. It could be a vibration to get things to start freezing and transitioning from having enough energy to remain liquid to only having enough, not having enough energy to remain liquid and having to solidify. But so that could be anything that's cold enough or other stuff. But some things might be more interesting to nucleate with than others. So yeah, maybe it would be more interesting to nucleate on bismuth oxide. Or another thing that happens in semiconductor manufacturing, because they're really interested in crystal growth and continuing crystal growth there. They call that, when you continue a crystal growth, that's sometimes referred to as epitaxial. For epitaxial growth, you need to make sure that the thing you're growing onto your substrate has close lattice parameters. And lattice parameters how far apart the atoms or molecules are spaced. And it might be the case that that there's some other material out there, and I don't know what it would be, that has a very similar lattice parameter to bismuth. That's say, and it would be especially convenient if it's inert to oxygen in the atmosphere and easy to clean. In which case, then maybe you could get a crystal of that material that has the same atomic spacing as bismuth crystals, and you could use that as a seed crystal for bismuth. Even though there'd be different materials, having the atoms have the same spacing could lead them to work together the right way that you'd want. I don't know if that would work and whether, but it's sort of a possibility. So and it would be interesting. Okay, we weren't very frozen there, so now we're plenty molten, and we'll continue doing the thing with the oxide here, with the skimming, with the slag. Another word for slag is dross sometimes. Polonium is the only element which crystallizes in simple cubic in ambient conditions. Well, I generally want to stay away from polonium, but that is very interesting to know. And fortunately for all of our simple cubic needs, we can turn to halite or table salt, sodium chloride. Yeah, it needs to have 2 elements in there, but they're easy to come by in the ocean, and you can also find them rock salt in the ground, and then you can get some good simple cubic crystals. Okay. So try the cold point strategy again, maybe this time with a little bit of copper wire that I keep on the side. And so I'm not going to try to grow stuff onto the copper here. I'm just going to try to use it to get the metal cold at that one point. I'll give another skim here. This is probably getting pretty close to crystallization time. So I'm just going to touch this in here and pull it out. Okay, so hopefully that's enough of a cooling there to do something, but we'll see. We may just get crystals everywhere else. Could also try with the tip of the tweezers here. Sometimes it'll work pretty well. Sometimes it won't. And tap the. Oh, okay. So this one here has definitely caused something to happen over here. This one, I think maybe all of these except the first one I did with the copper wire are doing something. I will try to scoot this one a little more into the middle, and that way cause more stuff to happen where I just touched it. This one I didn't touch, but it's just sort of close to the wall, and I'm just gonna grab it. It just happens to be a nice random crystal that I didn't intentionally do anything to cause, although it's small, but still pretty nice. Camera refuses to. There we go. It's not bad. Yeah, that one is taken off. This one's doing something. The grab. It's tilting everywhere as I try to. Oh yeah, that okay. That was. Sometimes they just sort of get away from you. But still not bad. Gotta be careful using my hand for fun. I should do it next to it maybe, so that it doesn't drip molten bismuth on me. That would not make me. That would not make me happy. I'd feel very embarrassed if I did something like that on stream. Streamer gets molten metal on themselves. Not a good look. Not a good look for me. Not a good look for Twitch. This is, okay, so this one I think was one of the other cold points. Not a whole lot happening here, but it is. So one of the things you can hopefully see here is that these two main crystals here are sort of at different angles to each other. Actually, and it's more like 3 crystals. Hopefully we can, definitely need to, it's nice as this cheap camcorder I got from eBay is, it leaves something to be desired on the focus field. So I'll be figuring that out more for the future probably. And then I think I've let this one go long enough. Oh, come here. Yeah, okay, so we got a pretty good chunky one from here. All I did was touch the bismuth oxide at the surface with the tweezers a little bit. And yeah, so we got a pretty good cluster here. Like 1, 2, let's see if we can point a little bit better. 1, 2, 3, 4. 4 at least 4 major crystals on here that, like, you know, kind of grew out of that, just it being extra cold at one point. And you can sort of see at the nexus there that they sort of grew from not much, from a common sort of start there. So I think that worked pretty well. It's something that I'm interested in trying more at some point. I could imagine it'd be really cool to have like a hollow copper tube that was closed at the bottom like a spike, sort of like a thermometer, except filled with like a heat transfer fluid, so that it would, like, you dip it in there, and then inside the tube where it wouldn't escape, it would boil away something to really cool off the bismuth quickly, and try to do more of that. But again, I think, you know, depending on how fast you cool it, you might just get a cluster of tiny crystals that you weren't as excited about. So District 10 Mushrooms asks, oh, and I've seen your stream. Cool stuff. I hope to hang out there again in the future. I tap it. Sometimes the tapping vibrations let me see by the ripples where the crystals are forming. And oh, I see. I had my my other self asking for stream. So I'm stepping away for a second to drink some water. And oh, there goes the cheap camera warning again. Okay, some good dice some good dice discussion, and other things. Yeah, I've been well. One of the reasons I decided to try streaming Bismuth, I've thought about it for a while, but I've been noticing an increase in the quality science and engineering and technology and education content of Twitch from people looking at cool stuff through microscopes to talking about dinosaurs to talking about volcanoes to all sorts of stuff. So I'd like to see. I love video games. I'd like to see a lot of that. I might even stream some at some point. But yeah, I'd like to see this sort of thing, and and this is part of that I can contribute to maybe. All right. So yeah, melted everything. Hopefully not too much. Now, yeah, so if you're just joining us, I'm skimming off the bismuth oxide at the surface, revealing for just a moment a silvery layer of pure molten bismuth underneath. But you can see that it quickly oxidizes and changes color. I feel like this camera could be pointed, or sorry, the light could be pointed a little bit better here. I think, yeah, the colors are coming through. Not super vivid, but they're not super vivid in real life right now. But yeah, as the oxide is revealed, as the pure bismuth is revealed, the oxide grows, changes color, and sort of grows in thickness and eventually just turns sort of silvery. But yeah, so, and then this is the point where you might have just seen me sort of tap the thing to see whether, there's any sort of wobbly squares or wobbly triangles in here. Probably there's probably stuff growing at the edges. Like earlier in the stream, I let it crystallize for a while, and then poured out the metal into this bowl, leaving this behind. That means there's usually always lots of crystals growing like this on the inside of the pot. But the easiest ones for me to get are the ones floating at the surface. I'd rather not spend my time breaking these apart. So I'd rather just melt and cool. But that is what's happening. But I'm looking for the ones that are on the surface because, again, to reiterate, bismuth is one of the few materials that is denser as a liquid than as a solid. That is, it's lighter as a solid than it is a liquid, or that it floats on its own melt. Okay, so, and we've got a crystal growing here. You may be able to observe the triangular shape that I'm trying to trace with the tweezers here. There's maybe something happening. Nope, nothing happening there. Sometimes it's an illusion. But if I tap it a little bit, you may see this triangular outline become a little bit more apparent. I think I can make it out on the video feed now as I look over at the computer screen at OBS. Something happening here. I'm just gonna, this one it's a crystal that's growing. It's really close to the wall. I'm gonna try to move it away. I may have just caused it to do a bunch of clustery stuff by nudging it, but we'll see. I'll let this one go a little bit longer. And I think, yeah, this looks like my camera's battery will die soon. It's just about 10. I've been trying to think of things to say over a pot of metal for about 2 hours, which is not necessarily a long Twitch stream, but is long enough for my first proper Twitch stream. So after I pull a few things out of this, I will start winding down. We'll call it a night. I might stick around for a little bit. I'm probably not going to try to raid anyone tonight, but thank you all for coming and watching this. And I'm not going anywhere right now, just setting expectations that the stream will not go on terribly much longer. This one just broke right as I picked it up. But we still got another one of these sort of typical little cuboid rhombohedral. I think someone asked about rhombohedral earlier and I forgot to respond, but I believe yes, the crystals are rhombohedral. They look sort of cubic, but the angle is not very far off 90. Or they look cubic, but they're not cubic. They have angles that are close to 90, but not 90. That's a better way to say it, which means that they're rhombohedral instead of cubic. Oh, and that's my, even have a, it's 10 o'clock alarm, which has gone off, which does not mean I'm going to cease streaming immediately, but yeah, we're going to shake this one off here. Show it to the camera. Let's see if I can hold still and maybe get a good time lapse of the color shifting here. I don't know, I should try to make some GIFs at some point. Or yeah, and GIFs are good too. I like to say GIFs. I think it's the animated giraffics format, but I understand some people will disagree. With regard to the sharpness, I think one of the things that helps is that I'm shaking it off a little bit, which is a little bit risky, but I just try to keep it below the plane of the pot when I do that. Although I hit the wall over here, obviously, and I got a little splatter there. Usually those tiny little drips of bismuth are not a big problem, and fortunately they don't come towards me. And I've had one or two stuck to a lab coat once or twice, but not too bad. And yeah, so that might be a thing for the rounded edges. Oh, and going way back to when people asked about toxicity, yeah, bismuth is in Pepto-Bismol. It's not as toxic as lead. Too much bismuth could give you some kind of mild poisoning. I think it can show up as a line on your teeth that sort of precipitates. But the main reason that you shouldn't eat bismuth crystals is because they're very pointy. It would be very uncomfortable. So also it would probably be like, I have to imagine it would be like chewing tinfoil, but way worse. So like, yeah, don't eat bismuth crystals if you come across any. Not food. It'd be cool to make candy that looked like bismuth crystals. Maybe see if you could get rock candy or sugar crystals to form hopper crystals. That would be neat, but don't know how that would quite work. I think, gosh, a Reddit fight over the pronunciation of GIF. Yeah, well, it could be, worse. There's worse ways you could spend time on Reddit. Oh gosh, and there goes my camera. I don't know if it warned us first. It might be done. I will definitely do this again sometime. And yeah, and maybe I'll have a background for when my camera runs out of battery. But more importantly, I should have a steady power supply for my camera, and a few other things to entertain you. And one of the things that I would like to show, though it requires some patience, is what happens when the bismuth freezes over. Since it expands as it freezes, it winds up squeezing liquid out of the center, and that looks pretty cool. So it sort of crusts over, and then the little bloop will appear at the surface. But yeah, with nothing but a dark screen, no cool outro music or anything, I will call it a night. Thank you all again for coming, and maybe see you next time. Have a good one. Take care. Bye.